morning everybody. I am here to explain the chapter Cylinder, Cone and Sphere in the 10th ICSE textbook. I explained all of these shape by using real life examples. First one, cylinder. For getting better idea, I am using a banana stem. This is a banana stem. This length, it is the height of the cylinder, and the radius can be taken like this. This is the radius, and the length of this stem is considered as the height. For getting volume of cylinder equal to cross section area. Cross section area for any regular shape solids, it is equal to the volume of any regular shape, that is from top to bottom it is regular in shape. Then volume of cylinder is equal to cross section area into height. Here cross section is a circle, therefore pi r square. This is a circle, therefore we use as pi r square into height is equal to h. Then volume of cylinder is equal to pi r square h. We get the formula pi r square h. Then total surface area. Total surface area equal to curved surface area plus cross section area, 2 cross section area. I explains with this example. Here is a cross section and here is a cross section, and there are 2 circles as cross section, that is 2 into pi r square plus this is the curved surface area, therefore it is 2 pi r h. By simplification, 2 pi r into r plus h. This is the total surface area of a cylinder. The curved surface area is equal to this perimeter. Here this is a circle, therefore this is equal to circle, perimeter of circle equal to 2 pi r. Circle perimeter is equal to 2 pi r and area equal to pi r square. 2 pi r into 2 pi r into this can be demonstrated by this experiment. This is the circumference of the circle. Circumference of the circle, and this is the curved surface area. Then I cover it with a paper. The area of this paper will be the curved surface area. Then this is the area. It is like a rectangle. This length is equal to 2 pi r and here the measurement h. Therefore this is like a rectangle. Area of rectangle is equal to L into V, that is equal to 2 pi r into h. Therefore we get the formula 2 pi r h. Volume of a cylinder is equal to pi r square h. Total surface area is equal to 2 pi r into r plus h, and the curved surface area of a cylinder is always equal to 2 pi r h. Next, here is a cone. I uses to show the shape. This is a banana stem, part of banana flower. Here, this is the apex of the cone, and the height of the cone equal to the distance between apex to the bottom circle center of the circle. This is the height. It is represented by h, and here is a circle, and we can take this r from here, and this slant height, it is represented by L. The h is inside and slant height is here. It is the sloping height. Here it is the sloping height. Height of the cone is from apex to center of the base. But slant height is this blue colored thread. Then there is a relation between H, R and L. This is a cone and H. This is the H. And here it is L. L is this, and the radius is this. We get a right angled triangle. According to Pythagoras theorem, L square equal to, here it is 90 degree. Therefore, L square is equal to H square plus R square. Or L is equal to root of H square plus R square. The volume of this cone equal to 1 by 3 pi r square h. Pi r square is the base area and h is the height. Volume of this cone equal to 1 by 3 pi r square h, where r is the radius of the circle and h is the height of the cone. Here, this is the curved surface area. Curved surface area of this cone is always equal to the sector area. When we cover this area with a paper, then we get a sector. Area of sector is equal to pi r L. Sector is like in this way. Therefore, L R it is equal to pi r L. Area of sector is equal to pi r L. Here is a circle also. Base area of the circle is equal to pi r square. Therefore, total surface area of this cone equal to pi r square plus pi r L equal to pi r into r plus L. This is the total surface area of this cone. Also, CSA or curved surface area. This is the curved surface area. It can be calculated by using the formula pi r L. This is L, and the inner height is represented by H, and this slant height is this. This is represented by L, and this is the R of the cone. Always area is represented by the unit centimeter square, unit, centimeter square or meter square, and volume must be represented by cubic unit. Next, sphere. Here is a typical sphere. This is a passion fruit, and volume of this sphere equal to 4 by 3 pi r cube. That is, it is equal to, inside this shell there is syrup. That is volume of syrup plus shell equal to 4 by 3 pi r cube. When we squeeze out the syrup from this fruit, we get the shell only. Then volume of spherical shell equal to 4 by 3 pi. Here it is capital R. Volume of syrup plus shell is capital R with capital R. Pi capital R cube minus 4 by 3 pi small r cube. Here 4 by 3 pi r cube represents the volume of syrup inside this fruit, and 4 by 3 pi r cube represents volume of syrup plus shell. Therefore, volume of spherical shell only, it is the difference between shell and shell with syrup and syrup only. Therefore, we can simplify in this way: 4 by 3 pi capital R cube minus small r cube, where R is the center to circumference, capital R represents, and the center to the inside portion of this shell represents small r. Here is a shell, that is the cross section of a spherical shell. Here is R, and the total distance from the center to outside, that is the circumference, it is capital R. Then the volume of this spherical shell without syrup is 4 by 3 pi r cube. It is known as the shell. Next, hemisphere. This is a sphere. Next, hemisphere. Forgetting hemisphere area volume, it is, I cut it. This is a hemisphere. It is half of sphere. Here it is another example. This is half part of this fruit, and it is almost like a hemisphere. Volume of solid hemisphere equal to here this is a solid hemisphere, then it represents R is equal to 2 by 3 half of sphere, that is 4 by 3 is the volume of 4 by 3 pi r cube is this volume of sphere, then 2 by 3 pi r cube is the volume of hemisphere, and a total surface area. Total surface area equal to, here is a lemon fruit. This is a lemon fruit for showing this solids. Neglecting the outside skin, this is a solid hemisphere. This is flat surface represents a circle. Therefore, total surface area of a hemisphere equal to pi r square. Here is a circle, therefore pi r square plus when it is for a sphere, it is 4 pi r square. Therefore, half of 4 pi r square equal to 2 pi r square. This is the curved surface area. Curved surface area of a sphere is 4 pi r square. Therefore, curved surface area of hemisphere, it is half of it, and therefore it is 2 pi r square. Here are two surfaces, curved surface and flat surface. Here flat surface is a circle. Therefore, we use pi r square, and here it is curved surface. We use 2 pi r square. That is equal to 3 pi r square. Here also volume represents by cubic meter and area represents by cm square. Here is a spherical shell. Spherical shell, there are two surfaces. Here it is 2 pi r square, capital R square, because the radius from center to this portion, it is it represents by capital R. Then this outer surface area, it is half of sphere. Therefore, for a spherical shell, the outer curved surface area is pi capital R square, 2 pi capital R square. Inner curved surface area, this small r represents the radius from center to this portion, inner portion, that is 2 pi small r square. Here also a ring. It is like a ring. For getting this area, we uses the formula pi capital R square minus small r square. Pi capital R square minus small r square. Through simplification, we get a simpler formula. 2 pi capital R square plus 2 pi small r square plus pi r square minus pi small r square. 2 pi r square plus pi r square, it is 3 pi r square plus 2 pi r square minus pi r square, it is pi r square. And pi into 3 r square plus r square. This is the total surface area of a spherical shell. The volume of syrup only, it is 4 by 3 pi r cube minus 4 by 3 pi small r cube. In the case of hemisphere, it is 2 by 3 pi r cube. The volume of syrup is equal to volume of inner part, that is, here it is the syrup, equal to 2 by 3, because it is a hemisphere, 2 by 3 pi capital R cube minus small r cube. Total surface area of this hemisphere, it is, here it is 2 pi r square, and here it is filled with the syrup. Therefore, we can use the formula pi r square. The volume of syrup only is pi capital 2 by 3 pi capital R cube minus small r cube. Next, pipe. This is a papaya stem. There is a hole. It is almost like a pipe. Here it is the center to outside circumference. It is capital R, and from center to inside portion it will become the small r. And then the volume, the height or length of this stem be represented by h. Then the volume of this pipe can be calculated by using the formula area of cross section into height. Here it is a ring. Therefore, pi capital R square minus small r square into h equal to pi capital R square minus small r square into h, volume of pipe. Volume of pipe is equal to pi capital R square minus small r square into h. When we fill with some quantity of material, then the quantity of material would be the pi r square, that is the inner radius only. And when we fill with some quantity, then the volume of total volume of this pipe, when it is filled with some any material, then it will become pi r square h. This is a part after removing a cylindrical portion from this inside portion. Internally cut out a cylinder, from it we get a pipe. From cylinder, a small cylinder is cut out, and then we get a pipe. Here, surface area. Here are two surface areas. Here is one of the surface area, and inside this there is another surface area. Outside surface area is this, and inside surface area is inside this portion. And this can be the outside surface area. Outside surface area equal to 2 pi capital RH. 2 pi capital RH can be demonstrated in this way by covering a paper like this. We get the length, and this is the height. Then L into B get the area of this portion, that is curved surface area 2 pi RH. And inside, similarly in the internal portion, inside, that is internal curved surface area is equal to internal CSA is equal to, this is external curved surface area, and internal curved surface area is equal to 2 pi small RH. 2 pi r represents the small circle inside the bigger circle. Internal surface area is equal to 2 pi RH. For getting total surface area, there are two portions also. Here is a circular ring, and here also a circular ring. Therefore, total surface area is equal to 2 into, this is the circular ring. That is, here is a bigger circle and a smaller circle without any material. Therefore, this portion cut out. Then we uses the formula pi capital R square minus small r square. Here is a bigger circle and a small circle is cut out from it. We get this area. this area. Here is the material, that is this portion. This portion is this. And height is equal to this. And for getting surface area, 2 into this area, that is bottom side and top side, 2 pi capital R square minus small r square plus 2 pi capital RH plus 2 pi small rh equal to 2 pi into r square minus small r square can be factorized in this way, plus from here you can take 2 pi h as common, then r plus r. Here are two common factors, r plus r into 2 pi. Therefore, here it is r minus r and here h only plus h. R minus R represents capital R minus small r represents the thickness. Therefore, R minus R is equal to T and this equal to 2 pi capital R plus R into T plus H. This can be using by the unit cm square or square unit. The symbol square unit. This is the total surface area of this stand. For getting volume of this water, it is almost like a cylinder. Therefore, the radius of this circle into height, that is the water level, by using the formula pi r square h. Here r can be taken from center to circumference, that is from here to the end of the circle, that is circumference of the circle, and h can be taken by using a small scale, and from these measurements we can calculate the volume by using the formula pi r square h. Here is a coconut, half part of coconut. This also represents a spherical shell. When we fill it with some material, then it will become a hemisphere, and the volume of this part, that is the coconut part, can be taken calculated by using 2 by 3 pi capital R cube minus small r cube. The r can be taken from center to circumference of this circle, and the small r can be calculated from can be taken from center to this portion. Then 2 by 3 pi capital R cube minus small r cube, we get the volume of this coconut portion only, that is the white colored portion only. Here is a piece of pipe. This is almost like a pipe. The volume, surface area and weight can be calculated by using the measurements R, H, small r, capital R and H only. And then for getting weight, the density also the necessary part, because volume into density is the mass of this material. Here is a ball. It is almost like this is like a sphere itself. The total surface area and the volume are calculated by using 4 pi r square and 4 by 3 pi r cube. the mass can be calculated by using the formula volume into density. Materials I uses for understanding the